Hello everyone, good evening. Welcome to the session. Today we will talk about error managing design patterns in our data engineering pipelines. What differentiates just a pipeline and a production grade system? It is not the presence of errors, it's the ability to detect, isolate, or recover them gracefully. And today we will see few patterns which you can follow to track the errors, trace the errors, handle the errors in your pipelines. Fail fast plus centralized logging of errors. First, we will look into this. Yeah, sorry guys. Fail fast plus centralized logging. Let us take this one pattern. Let us say there are CSV files coming from some e-commerce store, not e-commerce, let's say offline stores. There are in different areas, 100 plus stores are sending data every day. One day, a new store sends a file with two extra columns. Let us say store region promo code. What happens? Few things happens here. Spark loads the files, but drops the extra column silently. So you are missing the attributes that are coming. Wrong aggregations, no visible errors, data is getting skipped silently. And that is where we can, in these kind of scenarios, we can use fail fast. What fail fast will do, when schema doesn't match, it will immediately stop. So usually most of the transactional databases has this feature. But when coming to data warehouses, data lake houses, they accept data. They are flexible in these type of scenarios, especially using NoSQL databases, like data warehouses, data lake houses, they are like flexible in, they'll accept the schema changes. Sorry. So in such scenarios, this will be helpful. Fail fast plus centralized logging pattern. Not only stopping the pipeline, immediately logging the issue centrally, notifying the team. These two things will help to fix the thing straight away without any errors, without any loss happening. We can avoid data loss and also fix the error straight away when it occurs. And here is an example. CSV arrives. First, we will check the schema. If it is mismatching with the schema which we have planned for the table, then stop it and log to ELK. So some example code. When there is a schema drift expected, stop it and raise a value error schema mismatch detected and route this data to another table like rejected data or error data. Let us take another scenario. And in few cases, especially in today's world, data is not only coming from the structured databases, we have to collect data from third party people. For example, a e-commerce site want to know what is the geolocation of the customer. Today we have apps tracking our location, especially food delivery apps and other apps. They'll track your location accordingly, app will get updated. And in the backend database, same thing happened. Obviously, these uses third-party applications, something like Google Map API. They'll get data from there, like weather data, regional codes, government-related data. All these data, sometimes we need for our analytics. We will get this data from third-party websites or third-party vendors through APIs. When we do that, if there is any glitch, suppose that web page is not available, that API is not available, what happens? Your pipeline will try to again connect with that API. Again it will retry, again it will retry. And it will keep on retrying, which we don't want. We want sometimes our pipeline, especially the ingestion part of the pipeline, to back off, which we also call as circuit breaker. Don't keep on retrying, like wait time as 1 second, 2 second, 4 second. Don't do like that. Instead, if 10 calls fail, stop calling the API for next 10 minutes. First of all, retry with back off, sorry. Instead of calling the API for every 2 seconds or 4 seconds, like increase the time. You're getting repeatedly this error 503 or page not found errors. When API returns such kind of things, increment the wait time. Like the first attempt, it has to take 1 second time interval. And after 2 seconds, next retry. After 4 seconds, next retry. After 10 seconds, it has to wait. This will save a lot of compute power. And yeah, that is circuit breaker. Next, error designing, error pattern, handling error pattern designing is dead letter queue. In dead letter queue, streaming platforms like Kafka. This is for streaming platforms like Kafka, PubSub, and we have different variety of streaming platforms. Hundreds of streaming platforms are available. Open source or cloud, whatever it is, you know that data that is coming in real time, you might be collecting it from social media or IoT sensors or some other data that is continuously coming, and that is having some bad data. Out of the 1 million daily messages, 20% are corrupted, invalid values. For example, your end analytics is based on timestamp, and few messages are coming with null values in the timestamp, or out of ranges are there. Like some quantity column is having negative values. Some bad data, corrupted data is coming into your Kafka streams, which we also call poison messages. Why? These invalid records will break the entire stream. This is something related to stream processing. You want to process these messages as soon as they arrive. Something like analytics in stock market. Uh, they want to show like top 10 gains, top 10 losers in the market, live tracking, live monitoring. These kind of data we want to process straight away, IoT data. And if any bad data comes, the logic which you have written for real-time processing will fail. Right? Invalid records breaks the entire stream. So instead, what you can do, first you check the data. Before you directly apply the logic on the data, first you check the data. The key elements, like what attributes you want to be there. If they are null, reject the data. Instead of just rejecting the data, send it to a dead letter queue. That data is bad data, corrupted data, send it to a dead letter topic, which helps to helps the real-time streaming to run smoothly. Not only real-time processing, at the end user side, if the end user is something like storage, you are stopping bad data to get into storage first. So a lot of cleaning, error handling steps at later phases, you are stopping that unnecessary error steps and all. You are filtering that right from the scratch itself. So this is one method, that is routing bad data to another queue, which is called as dead letter topic. See here we have an example. Kafka message comes and you'll check the JSON data. If it is good, process. Otherwise, send it to dead letter queue. Idempotent consumer or idempotent rights. What does this mean? Let us take an example. Payments can be retried by upstream systems. Sometimes they might make twice, especially this happens when you are using data streams. Because these data streams, they'll try to deliver at least once, not exactly once, at least once. Sometimes due to some glitches or late arrival of messages, when these type of glitches happens, network glitches, your Kafka stream might deliver the same message couple of times, which is nothing but duplication. And we have to plan some pattern at the consumer side. The consumer side is a dashboard, a real-time dashboard, or automated dashboard, or real-time processing, or some other process is running as a consumer. We don't want to send duplications to the consumer side, or consumer should be able to detect the duplications. So that is nothing but idempotent consumer. For this, what we can do, for every event, give a unique ID. Instead of just putting messages in Kafka, give one unique ID. For example, timestamp or event ID. One unique attribute should be there. Based upon that, consumer should be able to track like that timestamp or that device ID or some attribute in the data should not repeat with other data, unique event IDs. So if there is any duplication, it will drop the data which arrives later. It will pick up the data which comes first. Schema and data contract validation. So this is one more thing. Usually, when you extract data from OLTP systems, there is structured databases. It could be some sales database or employee database. Usually, they are structured. Like the set of column names or attributes that you get always into your analytics systems will be same. You don't expect additional columns, missing columns. There won't be issues like this. But in some scenarios, in upstream, that is people who are managing the actual database, like say pharmacy is entering all its stock into some database. From there, we are extracting the data daily and processing that data. And finally, something like forecasting model is built on that data in data warehouse at an later stages, analytic stages. And this pipeline runs smoothly because this is structured data. Every time when a new stock comes as well as billing happens, that data will be entered manually or automatically into the table. And the ETL pipeline extracts the data, transforms the data, loads data into proper format into data warehouses. And from there, analytics like forecasting models, dashboards can make use of that data, guys. Now, let us say without notifying the later part, that is ETL part, upstream people has altered the tables. They have dropped few columns, added few columns. Like for example, they removed salary grade, added employee type. So in some employee table, what happens? Downstream joins fail. What you are doing? Based upon these two different tables, salary grade and let's say there are two different tables. As a part of your transformation, you are joining that table. For example, let us come back to our pharmacy example. A product stock table is there and billing table is there. And in later part in your ETL, you are joining both the tables to build your dashboards access that joined table. And also feature store is built on that joined table for later part of analytics. Now what happens if schema is changed? That joins will fail. The entire pipeline will get disturbed, corrupted, and errors will be flowing throughout the pipeline in different places of the ETL. And to detect this, there are tools like Great Expectations, schema registry. What they'll do when there is schema drift, change in the schema, they'll stop the pipeline. For example, additional columns, mismatching data types, some values which are not expected to be null, there are null. Some values are out of range. And these are like very crucial rules the data should have. If these crucial rules, the data which is coming is having additional columns or missing columns, if it is failing to satisfy these crucial rules, that data will be rejected. And there are tools like, for example, in open source, we have Great Expectations, Schema Registry, and in cloud, we have different validation tools. And before triggering your ETL pipeline, first you validate the data. Simple. And what rules you will are very important. You will apply those rules and validate the data. Past data will come into your ETL pipeline. Failed data will go and save in some rejected table, which you go on and look into the table. Whatever cleaning is required, or if you want to ignore that data, you can ignore. Or if that data is important, clean it, fix it, and use it in your ETL processing. And this method is called as schema and data contract validation. Sorry. Quarantine, that is creating error tables again. You see, when I say save the bad data in error table, here rejected data you can drop like that, or you can save it in some error table. Then what you are doing is schema and data contract validation plus quarantine. Quarantine is nothing but when there is bad data, save it in error table. Like that pattern, we are calling it as quarantine or error tables. You can use it along with schema and data contract validation pattern, idempotent consumers. If it is really important that duplicate data should be routed to some error, because you track like how often this duplications happening like that, then you can add that method here, like a hybrid method. Right, dead letter queue already we discussed. It's not a table. You're routing the bad messages, but not to a table, into a different queue. Now coming back, in this pattern, what you're saying, you are working with some data. It's batch data. It's already there. It's having lot of wrong codes, wrong numbers, missing, for example, in bank transaction data you got for analysis, negative transaction amounts are there, wrong currency codes are there, missing account numbers are there. Of course, if you say select everything from data frame or the table where amount is greater than 0, you'll get the correct data. But I don't want to drop that wrong data silently. I'll save that data which is having amount less than 0, which is having missing account numbers, to error table. So that is quarantine or creating error tables, which you debug later in detail, audit in detail later. Audit trail plus replay. And again, this is helpful for something like data coming in real time. Not only real time, any data like See, a logic bug is misclassified household internet expense category. Sometimes you'll get new data. For example, you're getting data from social media. You are getting from data from some third party sources, which is not in your control. Even the sensor data, these kind of data will come. Suddenly, the attribute names will change. Today, one attribute is called with some internet expense. Tomorrow, that name is called as some technical expense. I'm just giving an example. Change in the column name or data type. These kind of data will be coming in. Now you are accepting the data because you don't know what is the schema of that data in advance. So you have not created any tables. You cannot reject based upon that because it's not satisfying your table schema. For example, search requests, reviews, all these type of data. I don't know and I don't want to reject also because the data is not suitable to my table. It's not matching with my table schema because that data is coming from different types of external sources. It's not internal to my organization. And in some scenarios, we know that schema will not be right at all. So what we will be doing, we will be accepting the data as it is, saving in the bronze layer. Sometimes this data will be overwritten and you will go back to track that old data. There will be no record of original input. So when this happens, for example, let us say in Amazon S3 bucket, I am writing all the raw data which I am collecting. Due to some glitch, what happened? The data got overwritten. The data came with the same event ID or same timestamp ID or same file name. Same file came again with a lot of bugs or missing values. It replaced the old file. Now I want to go back and get the old file as well. But it is not there because any replay or audit trail versioning, not only audit trail and replay, versioning also is not enabled in the storage. If storage like S3 is versioned or we have data lake houses like Databricks, Snowflake, they'll automatically come with the audit trail, replay, time travel features, which is nothing but you can just go back to the previous version. So always choose your storage in such way where you will be able to audit trail and replay the data. Go back to the old version. In such scenarios, if data got replaced, if data got overwritten especially, sometimes we will overwrite the tables. So if versioning is available, I can go back. Replay is available, I can go back and restore the old version also, old data also. Okay, this method of choosing your storages or while you create the tables itself, if you create tables in such a way, along with versioning, audit trail and replay is possible. So this is one design pattern which tells you that choose the platforms or create tables or choose the storages with versioning. Okay, those are some patterns case. You can mix more than one patterns together. These are like best practices rather than saying patterns for error detection and correction in later stages. These are the patterns depending upon your data source, how it is coming. Is it batch data, streaming data? You can choose the right error designing pattern. Okay, thank you.